Hi everyone, this is Jindřich from Czech DC-9 project. I turned off the lights here in the workshop so that you see the specularity of the lights which are coming from the cockpit, and it's maybe not visible that much, but it is really spectacular. It looks pretty amazing. I go into the cockpit and I promise that I will record a video of the flight controls which we currently have connected to a motors that are providing us a lot of force on the controls. You see, this is a started aircraft because I can't show you that in action, but because we are leaking the license from Jan from the BFF, and he should send us that shortly, so I can only make short flights using all the BFF CL software. But what I can do is I have the tester software, so I can put a command to the force of the yoke or of the rudder pedals, so that they will do what I want. So now it's this software is set to give me a force proportional to joystick disposition. So if it's just a spring effect, if I move the yoke forward, it returns back automatically. Note we have 25 kilograms of force for the elevator axis, so I really need to pull hard to yes, like this, and it's very very hard to push and or move with it. There's another option. I need a mouse for that. And where is the mouse? I don't know where is the mouse. Okay, I'm going to try to find the mouse. It's on my table, I believe. Where's my little missy? So, let's go for some other test. I will now put a sine wave of 30 Hertz, and let's turn it on. So you will maybe hear some noise as the 30 Hertz you see, I can move it quite easy now, but what it does, it's just shaking on 30 Hertz frequency. So it can be simulation of, I don't know, rolling on the runway, etc. And I turn it off again, and let's do another axis number 2. I need again to reprogram it. So I put the sine wave into the aileron axis. So now you hear again the aileron axis is shaking on 30 Hertz. It makes a lot of noise and a lot of pretty good feeling in the yoke. I can also do the spring effect onto the x-axis, which is the aileron, and now again you see I can move it. It's 8 kilograms now to the left, and it's 8 kilograms to the right, so it's just a spring effect. The more away I put it, it's also not very easy. At 8 kilograms to this movement of the arm is very strong power. And now we can go to number 3, which are the rudder pedals, and again I'll show you how the rudder pedals do the spring effect. They do exactly the same. If I go to the right, that's 35 kilograms. They will just return. Sorry. it's now on, so they return to its neutral position. It's shifted to the left a little bit. We need to play with that somehow, but you see they are just it's off again. Why? I don't know. You see they return to neutral position, and I go to the right pedal and it returns back, so that's the spring effect, and the left is working the same way. So if I turn too hard it turns off, so there's some problem with the software anyways. But you see it's working. It's as I say 25 kilograms on the elevator, 8 kilograms on the aileron, and 35 kilograms on the rudder pedals. But it's really just to have this in hand. It just feels like it's not just that free. It just makes some natural resistance. So it's really cool and really accurate to move with the motors connected to all the axes. And guys, that's brilliant. I made some test flights today for the period that is allowed for the demo of the BFF, because we need new license. We use the old license to a notebook PC for testing, but as soon as we have the license I will record in-flight video so that you can see what it does when it stalls and what it does when it just rolls on the runway, or how the turns are, and so on. So guys, thanks for now. That's Hendrik from Czech DC-9 project, and hope to see you next time. Bye bye.